In this video lecture, we will talk about purification of colloidal solutions. Right? So before we go into detail of purification of colloidal solutions, right, let's just first understand what impurities are there in colloidal solutions. Right? So when a colloidal solution is prepared, it contains impurities of electrolytes. Right? We know electrolytes are salts, right? Inorganic salts like sodium chloride. So these impurities of electrolytes needs to be removed from colloidal solutions, right? So the process of removing these impurities to an acceptable level, right, from the colloidal solution is known as your purification of colloidal solution, right? So I use the word to an acceptable level. Why? Because these impurities in small amount is good for the stability of colloidal solutions. Stability of colloidal solution is a different topic. We would be doing it in a different lecture. But in this lecture, just understand that a trace amount or very small amount of impurities which are electrolytes is good for the stability of colloidal solutions, right? So the impurities are that of electrolytes, right? And electrolytes are crystalloids. Electrolytes, electrolytes are crystalline in nature, right? So they are categorized as crystalloids, right? And if you recall, in the first lecture of colloidal solutions, we have started that with an experiment, right, of Thomas Graham, where Thomas Graham allowed crystalloids and colloids to pass through it, right, through the animal membrane. He allowed crystalloids and colloids solution to pass through the animal membrane, and he observed that crystalloids could pass through the animal membrane, whereas colloids could not pass through the animal membrane. And it's because of the pore size of the animal membrane. The pore size of the animal membrane is such that it will allow crystalloids to pass through it, but it will not allow colloids to pass through it, right? Because colloids, we know, are bigger in size, right? And the pore size is such that it will not allow the colloids to pass through it, right? Now let's talk about it. So what is purification of colloidal solution? The removal of impurities of electrolytes from colloidal solutions to an acceptable level is known as purification of colloidal solution, right? So the process of removing impurities of electrolytes to an acceptable level is known as purification of salts, right? We also call colloidal solutions as salts, right? And right, removing the impurities or reducing the impurities to an acceptable level, because remember that trace amount or small amount of impurities are good for the stability of colloidal solutions, right? And the process of separating the particles of colloids, right, from those of crystalloids is known as dialysis, right? And how you will do it, like Thomas Graham experiment, what we will do is, since the colloidal solution consists of electrolytes, right, which are crystalloids. Since these are crystalline in nature, so we call them as crystalloids. And we have colloids, right, particles of colloids which are bigger in size compared to crystalloids, right? So these, right, this is allowed to pass through, it would be pass through animal membrane, right? It would be allowed to pass through the animal membrane, right? So animal membrane will allow crystalloids to pass through it, but it will not allow colloids to pass through it. So this is how the impurities of electrolytes, which are crystalloids, would be removed from colloidal solutions, right? So animal membrane will allow electrolytes to pass through it or diffuse through it. Right? And this process of separating crystalloids from colloids, right, by allowing the colloidal solution to diffuse through the animal membrane or parchment paper is known as dialysis, right? So the technique that we use to separate crystalloids from colloids is known as dialysis, right? So this technique is your dialysis, right, that will allow us to pass or diffuse, right, colloidal solution through the animal membrane, right? When you diffuse this impure colloidal solution through animal membrane, it will allow crystalloids to pass through it, right? This is how crystalloidal impurities or the impurities of crystalloids, which are electrolytes, are removed from colloids, right? And the most common application, first let's see this arrangement, right? The bag kind of thing that you see in black, right, this is animal membrane, right? So we will fold animal membrane in this bag form, right, and there is a funnel inside, and we will pour in the funnel, we will pour this impure colloidal solution, right, and this bag is in this container which has distilled water in it, right? So this bag is lowered in distilled water, right? Now in this bag we will pour crystalloids, we will pour impure colloidal solution through this funnel, right? And when this impure colloidal solution will enter into this parchment paper, right, then diffusion takes place. Diffusion of the solution, the impure solution, is allowed to diffuse through this animal membrane, right? So when it is allowed to diffuse, this animal membrane, right, will allow only electrolytes to diffuse through it or pass through it, right? So the blue the blue dots, right, that you see represents the colloid particles, and the red small dots that you see represents the crystalloid particles, right? So these crystalloids will start moving out of this bag into this distilled water, right? So since these impurities of electrolytes are moving out of this animal membrane into this distilled water, so this distilled water needs to be replaced frequently, right? Why? Because the impurities are now present in this distilled water have tendency to go back into this bag of animal membrane, because the pore size is such that crystalloids can diffuse through the animal membrane. So it has these impurities of crystalloids, which are electrolytes, has tendency to go back into this bag, right? So just to prevent that, this distilled water needs to be replaced frequently, right? So the plates that you see here, let's discuss about that now. Since we said that we are removing electrolytes, right, and we know that electrolytes contain positive and negative ions, right? So positive and negative ions are moving out of this parchment paper, right, through the pores of this parchment paper, right? So since positive and negative ions are moving out, and one thing, this process of dialysis is quite slow, right? So in order to speed up the process of dialysis, we put these electric plates, right? We put this electric plate, right, which has positive, these are negative and positive plate, right? So these negative and positive plates, when these plates are connected to the electricity, right, the negative plate will attract positive ions and positive plate will attract negative ion, and this is how it will speed up the process of dialysis. And when we use electricity to speed up the process of dialysis, this process would be called as electrodialysis along with these electrical plates, right? So electrodialysis, what it will do? Electrodialysis will speed up the dialysis, right, by attracting positive and negative ions of electrolyte, right? This is how it will speed up the process. And this water needs to be replaced, frequently, right? Why? Because these impurities have tendency to go back into the animal membrane, thus making the solution again impure, right? Now there is one important application of this dialysis technique, right? You might have heard of some patients that have kidney failure, right? When they have kidney failure, their kidneys fail to purify the blood, right? So now blood contains impurities, right? So these impurities needs to be removed from the blood. So what generally we do, there's a dialyzer. Those patients, how they are treated in hospitals is their blood is allowed to pass through a dialyzer. Dialyzer is a kind of artificial kidney, right? Their blood is taken from the arteries and allowed to pass through the dialyzer, which is similar kind of arrangement, right? Which will allow some particles to impurities to pass through it, right? And it will not allow crystalloids. It will not allow the colloids, which is hemoglobin in case of blood, to pass through it, right? So when blood is taken from arteries, it's allowed to pass through the dialyzer, which is an artificial kidney. It will filter the impurities and will leave the colloids, which is hemoglobin, in the blood, right? So blood is sent back into the body through veins, right, after filtering it through the artificial kidney, which is a dialyzer, right? So this is an important application of dialysis, right? So this is it in this process, right? But this is important, just make sure you understand everything, and just understand this is an animal membrane, right, which will allow only crystalloids, which are impurities in colloidal solution, to pass through it. It will not allow colloids to pass through it, right? So crystalloids are, when this solution is diffused, right, across this animal membrane, the crystalloids, which are electrolytes, will diffuse out of this animal membrane into the solution, right, leaving behind colloids, right? So this is how the colloidal solution is freed of impurities of electrolytes, right? Now there is a second method of purifying colloidal solution. The second process is called as your ultrafiltration. Filtration, right? So now just to understand it, we have been doing filtration, right, since our small classes, and we know that filtration is, if you filter a solution, right, the heavier particles will remain on filter paper, right, because they cannot pass through the filter paper, and the solution will come into the filtrate, right? So the same thing, just if you understand the same thing, you can understand ultrafiltration easily. Now, since colloidal solution, right, colloidal solution has crystalloids, which are electrolytes, right, plus colloids, right? So if we have a filter paper, right, if you filter that impure solution of colloidal solution, if it can retain, right, these crystalloids on the filter paper, or if it can allow crystalloids to pass through it, right, because our idea is to remove these crystalloids or electrolytes from this solution, right? So if the filter paper can allow these crystalloids to pass through it, right, leaving behind colloids on it, right. So this is how crystalloids and colloids can be separated, right. But this is not possible with the ordinary filter paper, right, because ordinary filter paper has pore size such that it will allow crystalloids and colloids to pass through it, right. So what we will do is the ordinary filter paper, what we do is we will treat the ordinary filter paper with a solution of colloidine or gelatin, followed by hardening it using formaldehyde solution, by dipping it in formaldehyde solution, right. So what all things we are doing here is we would be removing crystalloids from colloids, right, using a filter paper, right, which is different than the ordinary filter paper, right. So, and how we will prepare that filter paper which is different from the ordinary filter paper? By treating it with solution of gelatin, followed by hardening it by dipping it in formaldehyde solution. That ways the pores of filter paper that allows both colloids and crystalloids to pass through it will get reduced, right. This treatment of filter paper with gelatin solution and your formaldehyde solution will reduce the pore size such that it will allow only crystalloids to pass through it. It will not allow colloids to pass through it, right. So what we will do is we will treat ordinary filter paper with gelatin or collodion solution, right, followed by dipping it in formaldehyde solution to harden it. It will harden the filter paper, right. So via this technique the pore size of the filter paper will get reduced, right, and now the filter paper would be called as ultrafilter, right. The filter paper that we get after this treatment is known as ultrafilter, right. The filter paper is now called as ultrafilter, right. So now you will filter the impure colloidal solution with ultrafilter, using ultrafilter, right. So this ultrafilter has small pore size, right, and this technique is known as ultrafilter, and this treatment will reduce the pore size, right. That will allow only electrolytes or crystalloids to pass through it. Electrolytes or crystalloids will pass through the ultrafilter and colloids will remain on the ultrafilter, right. And these colloids can be added back to the dispersion medium and you will get pure colloidal solution, right. So this technique is known as ultrafiltration. When you do filtration, right, using ultrafilter, right, to remove crystalloids from the colloidal solution this technique is known as ultrafiltration, right. So I hope this is clear. The only thing that we are doing here is we are taking ordinary filter paper and then we are reducing the pore size of the filter paper so that it will not allow colloids to pass through it. It will only allow crystalloids to pass through it because the size of crystalloids is small. So after this treatment of ordinary filter paper with gelatin solution and then hardening it with formaldehyde solution. This will reduce the pore size of ordinary filter paper. Now it will only allow crystalloids to pass through it, right? And colloids will remain on the filter paper, right? Which can be treated with dispersion medium to get back the pure colloidal solution, right? So this is the technique of ultrafiltration, right? So I hope this is clear to you, right? So I'll just write here, ultrafilter will permit, which particle it will permit? Ultrafilter will permit only crystalloids to pass through it, right? Will permit solution of electrolyte to pass through it, right? Crystalloid is what? Crystalloid is electrolyte, right? So ultrafilter will permit solution of electrolyte to pass through it, right? And leaving colloids on it, right? So colloid would be treated with the dispersion medium to get back the pure colloidal solution, right? Just this is quite simple, right? Just you have to remember that ordinary filter paper needs to be treated with the gelatin and formaldehyde gelatin followed by formaldehyde solution. That will reduce the pore size, so it will allow solution of electrolyte or crystalloids to pass through it, and colloids will remain on the filter paper. That can be treated with the dispersion medium to get back the pure colloidal solution, right? Now we have a third way of purifying the colloidal solution, which is known as ultracentrifugation, right? That technique is your ultracentrifugation. Ultracentrifugation, centrifugal force, you know, right? The force that acts towards the the force that acts away from the center, right? If I recall it correctly, there is one centripetal force, right? Then the other is centrifugal force, right? So what normally we do is, in this ultracentrifugation, centrifuge is a kind of a device, right, which rotates or spins at a very high speed, right? So ultracentrifugation is when we remove the colloidal solution, when we remove impurities which are electrolytes from colloidal solution using ultracentrifuge, right? Ultracentrifuge is a device. What you do is, in this technique, you take colloidal solution, right, in a tube, right, and put that tube in this device called as ultracentrifuge, and ultracentrifuge rotates or spins at a very high speed, right, such that crystalloids will remain in solution and colloids would get settled at the bottom, right? Then you do decantation of this solution that has particles of colloids settle down, right? So this way, when you do decantation, the colloids will get separate from the electrolyte solution, right? Electrolytes will remain in solution, whereas colloids will settle down, right? So you can do decantation that will remove colloids from the solution of electrolytes, and colloids can be treated back with the dispersion medium to get back the pure colloidal solution, right? And this impure, so this solution that contains your impurities, right, of electrolytes is known as centrifugate, right? If I recall it correctly, we call it as centrifugate, right? So this process is quite simple, right? So the colloidal particles in this technique, just remember, settle down at the bottom of the tube, while the impurities will remain in the solution. These impurities are called centrifugate, right? So here you take a tube, right, and in this tube you add colloidal solution, right? You add colloidal solution to this tube, right? Suppose you have taken, this is the kind of tube, then you place this tube, right, in ultracentrifuge, right? And ultracentrifuge rotates or spins at a very high rate. So when this tube is in ultracentrifuge and it rotates at a high speed, it will allow colloidal particles to settle at the bottom, right? And the electrolytes will remain in solution, right? Colloidal particles will settle at bottom and impurities will remain in solution, right? And these impurities are known as centrifugate. The solution of impurities is your centrifugate, right? So this colloidal particles can be separated from it, right? And then the colloidal particles can be treated with the dispersion medium to get back the pure colloidal solution, right? So these are the three techniques that we have discussed to purify colloidal solutions that contains impurities of electrolytes, right? I hope all this is clear to you. Thanks.